This presentation is on the various activities you're required to do in genetics. And I'm going to go through one example in each. So in activity 1, let's look at the first one where we have the genotypes of the parents as this and this. So here it tells you that the parent is tall because this tall gene is a dominant gene, which is this one. And here it tells you that this parent is short, and the person can be short only when they have both genes of the recessive type. Now let's look at the probability in each pregnancy. So we draw the Punnett square, and let's say this is how the genes would break up in the father, and this is in the mother. Now when they combine, the child could have this combination or this, or we take this and this together, this, or this and this together, this. So here we can see that this person and this, either one of these would be tall. These two, let's use a different color. Would be short because they have both recessive. So the genotype would be 50% because out of a possibility of 4, 2 of them are this. So we have 50% would be this, and 50% would be this. This could also be written as heterozygous, and when you say heterozygous, that means obviously there is a dominant gene in it, and this we would say homozygous, but we have to say recessive because this too is homozygous, but this is homozygous dominant. But in this case, this is homozygous recessive. So you could write the genotype as 50% this way, or 50% heterozygous, 50% homozygous recessive. Phenotypically is what you see, and we just said these two would be tall and these two would be short. So there's a 50% chance of the offsprings being tall and 50% chance of the offsprings being short. So phenotypically is what you see. So this is the first activity. Now let's look at the next one where we have incomplete dominance. R and R is a red flower, and we have two lowercase is a white flower. So this is red and this is white. Now incomplete means that neither one is expressed dominantly over the other. So both express themselves, so you get a part somewhere in between. So let's again draw the Punnett square. So we have R and R from this breakup, and we have small r and small r. So when these two join up, this is what we will get. These two join up, this is what we'll get. These two join up, this is what we'll get. It doesn't matter how you write it. You could write it this way, or you could write it this way. Traditionally, we tend to write the uppercase or the dominant in front and the recessive behind. And this too is like this. So now this is an intermediate between this and this. So these are pink flowers. So if you look at this genotypically, you can see in all cases the probability is 100% is this, or what we would say 100% is heterozygous. Phenotypically, Again, these will all be pink, so we say 100% is pink. That's phenotypically, that means what you see. The next one is on sickle cell disease, which your book classifies as being incomplete dominance. I classify it as codominance. It doesn't matter. But let's look at this. So we have SS as normal hemoglobin. SS is a person with the sickle cell disease. And S is when they have the trait. That means they do not have the full-blown disease. So let's look at one example where we have these two parents, and let's see how their genes will work out. So this is how this will break up, and this will be this way. So here, this is how we are going to have this combined with this. And then when this combines, and this combines with this, we have this. So you see, in all of them, you have the trait. So no person would be absolutely normal. So genotypically, we would say 100% would be heterozygous or would be like this. And phenotypically, we'll say that 100% will show the trait. So in other words, whatever you see, that's what you're going to say for phenotype. So this is in the sickle cell disease. Let's look at a blood group Punnett square. And for blood group, as I posted in the discussion board, I said instead of writing it as the book says, if a person is homozygous A group, you write it like this. Instead of writing it this way, let us erase this and take a new page, and let's look at blood groups. So we write A group, suppose the person is homozygous A, you just write it as this. If they're heterozygous A, so they have one dominant and they have the recessive I. V group, the homozygous will be this, the heterozygous will be this. AB has only one possibility, and O is recessive, so it has to be this way. So let's say the parents, we have a heterozygous B group parent, so the parent, one parent is this way, and we have another parent who's O group, so that's this. Now let's draw the Punnett square. So this breaks up into this way, this will break up this way. Now we see the combinations. This B and this I, and this together. So you can see genotypes, 50% of the 4 possible combinations, 50% will be this or heterozygous B group, and 50% will be the O group, because we said this represents the O group. Phenotypically, we'll say that the person can only be a B or an O group. So this is how you do the Punnett square. So I hope that's been helpful.